Great day, students. My name is Mr. Bonzo from Oxford Study Center. I will be taking you for mathematics. Our first lecture, we are going to start with the number concepts. We need to define what a number is. A number is a way that we use to quantify. For example, we quantify the number of students using the concept of numbers. So, numbers can be classified into different categories. The first one is natural numbers. What are natural numbers? All numbers that start from 1, 2, 3, 4, 5 up to infinity are said to be natural numbers. So negative numbers are not natural numbers. The second category, odd numbers. What are odd numbers? Odd numbers are those numbers that are divisible by 2, leaving a remainder of 1. For example, 1, 3, 5, 7, etc. We move on to even numbers. Even numbers are best described as multiples of 2, or those numbers that are divided by 2 without leaving a remainder. For example, 2, 4, 6, 8, 10. Another class of numbers are prime numbers. Prime numbers are those numbers with 2 factors only, 1 and itself. For example, 2, 3, 5, 7, 11, etc. So 2 is the only number which is both even and prime. Now we need to look at the factor and multiples. All the numbers that are divided into 10 without leaving a remainder are known as factors of 10. For example, 1, 2, 5, and 10. All these numbers are divided into 10 without leaving a remainder. So we say 1, 2, 5 are all factors of 10. So 10 is a multiple to 1, 2, 5, as well as 10 again. Our first question is, express 50 as a product of its prime factors. So we want to look at the prime factors of 50. So we use the 2, 3, 5, 7 concept. The reason why we use 2, 3, 5, 7 concept is because 2, 3, 5, and 7 are the first 4 prime numbers. So of the 3 numbers, which prime number is divided into 50 without leaving a remainder? 2. 2 into 50, we get 25. Then we also choose a prime number which divides 25. That's 5. 5 into 25, we get 5. 5 into 5, we get 1. So 2 times 5 times 5. We have expressed 50 as a product of its prime factors. But we can also simplify 2 times 5 times 5 by writing in index form, which is 2 times 5 to the power 2. Remember, if the power is not given to any number, we assume that it is to the power 1. So 2 is to the power 1, 5 is to the power 1, and the other 5 is to the power 1. So we add 1 plus 1 to get 2, since 5 is similar. Our second example, express 100 as a product of its prime factors. express 100 as a product of its prime factors. So again, we are going to choose any prime number from the first three prime numbers that we have. I'll start with 5 this time. 5 into 100, we get 20. We can use 5 as well. 5 into 20, we get 4. We use 2 into 4, we get 2. 2 into 2, we get 1. So 5 times 5 times 2 times 2. 5 is raised to the power 1, raised to the power 1. So how many 5s do we have? We have 2. So it's 5 to the power 2 times 2 to the power 2. So the two answers are correct, but the second answer is the simplified version, which is 5 to the power 2 times 2 to the power 2. So I'll write the last example on expressing as product of prime factors. I'm going to express 26. 26 as a product of prime factors. The reason why I've used the 26 is because there is a difference between the first two examples that I want you to see. Which prime number divides 26 without leaving a remainder? 2. 2 into 26, we get 13. But as we can see, amongst the first four prime numbers, there is no number which divides 13 without leaving a remainder. Therefore, 13 happens to be a prime number. So we divide using 13. 13 into 13, we get 1. So it's 2 times 13. We have reduced 26. We have expressed it as a product of its prime factors. So for the first lesson, I think that's enough. Thank you.